What if we're not alone in the universe, but simply looking in the wrong way? Just 4.2 light-years away, an Earth-like planet orbiting our closest stellar neighbor might hold the answers we've been chasing. From strange atmospheric signals and puzzling thermal anomalies to intense magnetic fields, Proxima b is turning out to be far more enigmatic than we ever imagined. Now, with next-generation telescopes like NASA's Habitable Worlds Observatory on the horizon, we may be closer than ever to uncovering evidence of extraterrestrial life. Could this be the breakthrough we've all been waiting for? Let's dive in. Quantum AI, the key to unlocking Proxima b's secrets. Imagine trying to read a book with smudged pages and ink blots. You can make out a few words, but the full story remains hidden. That's exactly what scientists faced when analyzing data from Proxima b. For years, astronomers struggled to decode the massive volumes of information gathered from this potentially habitable exoplanet. Even the most powerful supercomputers couldn't handle the complexity. It was like trying to stream a 4K movie using dial-up internet, painfully slow, full of gaps, and nearly impossible to follow. Enter quantum AI. This groundbreaking technology doesn't just process data, it interprets it. While traditional computers rely on binary bits, zeros and ones, quantum computers use qubits, which can exist in multiple states simultaneously. That means they can explore countless outcomes at once, rapidly decoding chaotic and layered data that would otherwise be indecipherable. This breakthrough has revolutionized how we study distant worlds. Take the James Webb Space Telescope, for instance. When it observes Proxima b, it collects a massive amount of data, light spectra, atmospheric compositions, temperature patterns, and more. But before quantum AI, much of that data was unusable, clouded by cosmic dust, stellar radiation, and background noise. Quantum AI is now functioning like a next-level noise-canceling system, filtering out the static to reveal only the most important signals. Think of it as slipping on a pair of futuristic glasses that instantly sharpen a blurry image. And what researchers have uncovered is truly astounding. Among the most groundbreaking discoveries, strange, repeating patterns in Proxima b's atmosphere that hint at something remarkable. Fluctuating methane levels have been detected, levels that rise and fall in a consistent cycle. Traditional supercomputers completely miss this detail, but on Earth, such methane variations are often tied to biological processes. Could this be evidence of life on Proxima b? This breakthrough was made possible by quantum AI's unique ability to process vast, complex data streams simultaneously, spotting patterns that might take classical computers decades to uncover. It's no wonder that tech giants like Google and NASA are pouring resources into quantum computing. It's opening doors we never knew existed. And this is only the beginning. Quantum AI is already being used to enhance image clarity in NASA's deep space missions. Future telescopes powered by quantum technology could uncover even more about distant worlds like Proxima b, bringing us closer to answering that age-old question, are we alone in the universe? Each new discovery doesn't just sharpen our view of the cosmos, it redefines space exploration itself. Thanks to quantum AI, we're beginning to decode the universe's secrets. Among the most compelling, the strange methane patterns in Proxima b's atmosphere. They've sparked a wave of scientific curiosity. Are these the first real signs of alien life, or is there a natural explanation we haven't yet considered? Quantum AI may hold the key to identifying the first true biosignature. Let's dive deeper into what makes Proxima b so fascinating. Could this enigmatic planet be harboring the signs of habitability we've been searching for? With help from cutting-edge tools like the James Webb Space Telescope, we may be closer than ever to the breakthrough humanity has been waiting for. Some of the key chemical signs that life might exist, gases like oxygen, methane, and carbon dioxide, are deeply connected to biological activity here on Earth. So, if we detect a similar pattern on another planet, it could be groundbreaking. Recently, astronomers analyzing data from the James Webb Space Telescope, JWST, with the help of quantum-enhanced AI found something surprising in the atmosphere of Proxima b, fluctuating levels of methane. Why does this matter? Methane is one of the most compelling indicators in the search for alien life. On Earth, the majority of methane is produced by living organisms, like microbes or even cows. However, it can also originate from non-living sources such as volcanic activity, hydrothermal vents, or deep underground chemical reactions. That's why spotting methane on another planet prompts a huge question: is it biological or purely geological? Initially, the methane signals from Proxima b looked random. But after applying advanced quantum AI to refine the data, a striking pattern emerged: a regular, repeating cycle. This kind of rise and fall in methane levels is something we also see on Earth, where living organisms release it in seasonal rhythms. Of course, it's important not to jump to conclusions. Similar cycles could also be caused by natural, non-living processes like volcanic eruptions or chemical interactions beneath the surface. Scientists are now working to rule out these possibilities before suggesting anything too bold. The next step involves gathering more data, both from JWST and other telescopes, to search for additional gases often associated with life, such as oxygen or nitrogen. Finding multiple biosignatures together would significantly strengthen the case for life. The detection of methane on Proxima b is one of the most exciting developments in the quest to find life beyond Earth. While we don't have definitive proof yet, this brings us closer to answering one of humanity's greatest questions: are we alone in the universe? What do you think? Could this be our first real clue to alien life, or just another intriguing cosmic puzzle? Proxima b's atmosphere has long intrigued scientists, especially with its shifting methane levels that hint at possible life. But there's even more going on beneath the surface. Recently, researchers uncovered two surprising features: thermal hotspots and an unexpectedly strong magnetic field. These findings suggest Proxima b might be far more active, and potentially habitable, than we previously believed. So, what's behind these strange discoveries? Let's explore the latest mystery surrounding Proxima b, its unusual heat patterns and magnetic shield. Picture a planet locked in place, one side endlessly baked by starlight, the other trapped in frozen darkness, a common fate for worlds orbiting close to red dwarf stars. For years, scientists believed Proxima b, a rocky exoplanet circling the red dwarf Proxima Centauri, fit this exact profile. But recent observations flipped that idea on its head. Instead of extreme temperature differences, astronomers found thermal hotspots located in the twilight zone, the narrow band between day and night. This suggests that heat is somehow moving across the surface, defying our expectations. What could be driving this unexpected warmth? One theory points to volcanic activity beneath the crust, releasing heat and preventing the dark side from freezing. Another possibility is that Proxima b has surfaces rich in metals or carbon, materials that absorb and distribute heat more efficiently. Either way, it's a game-changer for how we understand the planet's climate, and its capacity to support life. But the surprises didn't stop there. Against all odds, Proxima b appears to have a strong magnetic field. Scientists once thought the planet was vulnerable to intense stellar winds from its active red dwarf host, which would have stripped away any atmosphere. But new research shows it orbits just beyond the danger zone, allowing its magnetic shield to remain intact. This is a critical discovery. A strong magnetic field can protect a planet's atmosphere by deflecting harmful radiation and keeping essential gases from escaping into space, key ingredients for habitability. With evidence of internal heat flow and magnetic protection, Proxima b is starting to look a lot more like Earth than we ever imagined. If it can hold on to an atmosphere, it might also sustain liquid water. And where there's water, the possibility of alien life becomes very real. We're just beginning to scratch the surface of understanding the hidden forces that shape Proxima b, but one thing is clear: this exoplanet is far more intricate and fascinating than we ever imagined. Could it be a second Earth? The answer may be closer than we think. Proxima b's unexpected magnetic field and thermal activity have reshaped our ideas about what makes a planet capable of supporting life. But as we continue to explore this intriguing world, a larger question arises: how many other planets in the universe might harbor life? The search for habitable worlds is only getting started, and with next-generation telescopes like the Habitable Worlds Observatory on the horizon, we're on the verge of discoveries that could change everything. The future of exoplanet exploration is full of promise. What if the next telescope we launch uncovers definitive proof of life beyond Earth?